doing, guys? So today for discrete math, what we're going to continue working with is we're going to continue working with codes, right? Different types of codes. And now what we're going to move into is something that's called binary code. I don't know if you guys have ever heard of binary code. It's actually something that's very interesting, and it applies specifically to computers, right? But we're going to see, since we're working with different types of way of representing code and how all these things are represented in the real world without us ever noticing, this is one of them, right? So if you've ever heard of binary code, you know that it deals with just computers. If you've never heard of binary code, you're going to find out right now that it's actually very interesting. So what binary code is? Binary code is the way that computers send information across the web, right? So when one computer is sending something somewhere else on another computer, they are always sending it through binary code. And what that means is, let's say you type in a paragraph, right? You're just writing a story, you're writing a message to your friend, you're sending an email, all that. You're typing it in words. When the computer is sending that through the internet, it's not sending those words. What it's sending is a bunch of numbers. And those numbers are what we call binary code, right? And binary code, it's just a computer language. It's a computer language that only uses two numbers. That's it. That only uses ones and zeros. That's all binary code is. Literally, it's a computer language that uses just the numbers 0 and 1. Doesn't use anything else. Everything is just all zeros and ones. So whenever you hear of the word binary code, the term binary code, all that means it's just a string of zeros and ones. And what that represents, that's a message that the computer is sending. That's information that the computer is sending, and that information represents something, right? It'll represent words, it'll represent numbers, it'll represent meanings, all of that. This string of 0 and 1s will have a purpose to them. And what we're going to start working with today is we're going to analyze how binary code can be used to represent numbers. Because again, all of this is just representations. So it is one of those things. Always remember, binary code, whenever you see it, just represents a bunch of zeros and ones, and it's a computer language. It's the way that computers send information to and from other computers, right? By using just the number 0 and the number 1, right? So let's go into how it actually represents it, right? And we're going to see what numbers these are representing and how to actually analyze them, right? So before we even get started, right? The thing about binary code is that binary code for numbers, we're just exclusively working with numbers, has a certain representation for each number, right? So for example, let's say I had the number 0, 0, 1, 1, 0, right? Let's say I had that. Now this set of binary code represents one specific number, right? And when I say number, think of the number 22, 45, 67, 13, 8. All of that gets represented binary. The way that we actually analyze what number is represented is because every single place, starting from the right side, represents a specific value. So the easiest way to actually show you this is by crafting a small table, right? Always. And it's always just realizing it in this regard, right? Always take into account that whenever you're analyzing this, it's always going to be the same thing, right? So the way that we look at it, always starting from that last one, right? Always starting at the right. That first number, whether it's a 0 or 1, it doesn't matter. This first place always represents the value 1, right? This next place always represents the value 2. The next one represents the value 4. The next one represents the value 8. The next one represents the value 16, and on it goes. So the more numbers you get, if you guys notice the pattern, the values, 1, 2, 4, 8, 16, it's always doubling, right? So if I were to put the next number here, if I was to put another 0 or 1, that would be 32, then it would be 64, then it'd be 128, then it'd be 256. All it's ever doing is just multiplying times 2, right? So again, these numbers here, this is never going to change. Whenever we're dealing with binary code, this is what it always is. The first number on the right always is worth 1, then it's worth 2 the next one, then the next one's worth 4, the next one's worth 8, the next one's worth 16. The way that we read this is that we're actually gonna see what values we have. So again, there's only zeros and ones, right? If there's a 0, it means we don't have that. If there's a 1, it means we have that. So if you see a 0, it means it's not there. If you have a 1, it means it's there, right? So like for example, since that's a 0, we don't have a 1, right? Since that's a 1, we have that too. So let's add that 2 in. So we didn't have a 1, we have a 2, we have a 4, right? We don't have an 8, and we don't have a 16. So the only reason that we have 2 and 4 is because we had a 2 and we had a 4. The way that you always know what you have is it'll have a 1. If it doesn't have it, it'll have a 0, right? So that's why we have those. And the way you figure out your number is whatever values you have, you always just add them up. And so when we add up 4 and 2, it's going to give us 6. So whenever you see this binary code, 0, 0, 1, 1, 0, all that represents is just the number 6. That's it. That's how the computer sends the number 6. Just a string of binary code. All of those zeros and ones in those specific positions represents the number 6. Because now once you start switching the positions, that's where it changes everything, right? So again, let's get comfortable with this. Always remember, if there's a 0, it doesn't have it. If there's a 1, it has it, right? And then always remember, if the numbers get bigger, which we're going to practice in the next couple of classes, if the numbers get bigger, it's always just doubling, right? 1, 2, 4, 8, 16, 32, 64, right? So let's try some more. And again, it is interesting. I actually found this to be interesting because again, it's one of those things that I never knew, I never learned about, but it does get intriguing to actually see how these things operate, right? Because all this is, it is ways for us to be able to send codes and computers to send codes without just specifically being able to focus on it. And in a couple of weeks, we're actually going to go into how people were able to send messages, coded messages back in the day through other ways. This is a way of coding, right? This is a way of being able to read code, things representing other things. So let's say now that I had the number, let's say I had the number 0, 1, 1, 0, 1, right? We have this digit right here. We have this sequence of numbers. Let's say I wanted to figure out what that's worth, what number that represents in binary code. Same idea, right? You're going to go one by one, and you're going to figure out the values you have. So, since there's a 1 there, that's worth 1. Since there's a 0 there, we don't have the 2. Since there's a 1 here, we have a 4, plus 4. Since we have a 1 here, we have the 8. Since we have a 0 here, we don't have a 16, right? So the only numbers we had was the 1 value, the 4 value, and the 8 value, right? We didn't have a 2, we didn't have a 16. So 1 plus 4 is 5, 5 plus 8 is 13. So whenever you see that, 0, 1, 1, 0, 1, all that represents, it's just the number 13, guys. That's how binary code works, right? It's just getting comfortable. But at the beginning, it should help to actually see that sequence there. I want to do 2 more, but I want to start seeing if you guys can get in the habit without seeing that, right? Without having that there all the time. Because there are times where you're going to start getting more comfortable. It's just feeling comfortable with it, right? Let's say that I had the number, the sequence of 1, 0, 0, 1, 1, right? I want to figure out what number that represents. Always start thinking, always from the right side, right? So again, just remember, we have a 1, that's 1, right? This represents a 2, this represents a 4, this represents an 8, that represents a 16, right? Always that, it's never going to change. First one's always worth 1, second one's always worth 2, then it's worth 4, then it's worth 8, then it's worth 16, right? Always doubling. So let's look at what we have, right? So we have a 1, right? We have a 1. We have a 2. We don't have a 4. We don't have an 8. That's why there's zeros. We do have a 16. So now we know 1 plus 2 plus 16. So 1 plus 2 is 3. 3 plus 16 is 19. So all of this, that is 1, 0, 0, 1, 1, all that represents is the number 16. This represents the number 16. That's what the binary code represents. It's actually very intriguing, I found. I'll do one more because I do want to see if you guys start getting comfortable with the pattern, if it starts getting bigger. Last one, let's say that we had the sequence of 1, 0, 0, 0, 1, 1, 0, right? Let's say I had this. It's gotten bigger now, but again, I want to see if you guys can figure out this pattern, right? Figure out what number is represented right there. Always remember, if it helps you, the pattern is always the same. Always start on the right. First one's always worth 1. Second one's always worth 2. Third one's always worth 4, because it's always double, right? Next one's worth 8. 4 times 2 is 8. Next one, 8 times 2 is 16. The next one, 16 times 2 is 32. Distance that a little bit, so since it's not right on top of each other, right? Next one is worth 32, right? And then 32 times 2, that one is worth 64. And that's what I mean. With the computer, it doesn't stop. It's just a big algorithm that is written to be able to handle all this and just constantly always be doing it because it's always times 2. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64, right? And now exactly what we've done. We're just going to piece these together to see what number this string represents, right? So let's see what we have. That's a 0. We don't have a 1. We have a 2. That's a 1. We have a 4. We don't have an 8. We don't have a 16. We don't have a 32. We do have a 64. Right? So the only 3 numbers that we had, the only 3 values we had a 2, we had a 4, and we had a 64. All the ones with the 1, right? 2 plus 4 is 6. 6 plus 64 is 70. So all of this, the 1, 0, 0, 0, 1, 1, 0, all that represents is the number 70. That's what binary code is. It's a way that computers, so when you type into a computer the number 70, the computer is not sending the number 70. It's sending this. And then when the other computer gets this, the other computer automatically is going to show you the number 70 because that's how they communicate. They don't send this. Computers are always sending binary code, bunch of zeros and ones to represent the information. If you guys have any information, let me know. Again, next couple of classes we're going to be working with this just to actually get comfortable and getting you comfortable with being able to represent numbers too. Take care.